This is my first time using this. Oh, oh, okay, cool. So it made me go live already. That's cool. It's my first time using it. That's cool. Oh, oh, okay, cool. So it already. All right. Let's see. I just casually use the Godot game engine. There's no direction or task. Take your shirt off. Take your shirt off. All right, dude. I'll do that right now. Let me turn on my camera real quick. Wait, why is my camera not coming on? Deactivate. Activate. There we go. Ooh, camera's on. You better see a show. Nah, I'm kidding. I ain't doing that, man. This is a professional stream. We don't do that kind of thing around here. We don't do that kind of thing around here, Bo. Alright. Anyway. I don't even know what I'm doing, to be honest. I'm just kind of doing things. What was I doing? So what I was doing right now, if anyone's interested, um, there's this issue that I'm having where when I run this, uh, I'm, this ain't OnlyFans. Nah, bro, you're in the wrong place. This ain't OnlyFans. But you can add my OnlyFans if if you want to throw me some dollar bills. All right. So the issue that I'm having is can't really see it because I changed the size of that thing. So let me change that back. If you want my OnlyFans, just DM me. I'll let you know. Wink, wink. All right. What was I doing? Crosshair Position, and this was because I did by multiplier, and oh wait, no, wrong spot. Multiplier, and this was times multiplier. All right, so you can see the this little square right here. The circle's like at the bottom of the square, um, and there's that little blue. There's a little blue circle right there, and I mean they're not lined up at all. And this little dot is supposed to be dead center of this screen, and it looks like it is. I mean that looks center to me. And then this square and the blue thing is obviously not center. I mean that's it. I don't know. Anyway, the way that I was doing this was I have this camera here and I have this raycast, and I mean it's centered. It's coming from the very center of the screen. I don't know if it's because of the perspective of the camera or if it's something's in my code is messing it up. I'm not sure, but even if I run this scene, like things are looking weird. And you can see this blue line go straight through the center of that cube. So I mean, it should all line up. I mean, it makes sense to me. But it's not. It's like way the hell down there for some god awful reason. No idea. Um, yeah, so I don't really know what the deal is with that. Let me run that again. Takes a second. Yeah, I mean that looks center of the screen to me. I don't get it. I wonder if it's taking account of this top bar up here. Because if I move this, like if I kind of imagine this blue bar being right here, doesn't that look like the same height? Like for example, like I put this, so like the code that I'm using to position this little white dot, like to my eye, it looks like, it's, if I were to draw a line here and then draw a line here, that's like dead center. But if I were to draw a line at the very top of the corner, like that looks like it's offset by that much. I wonder if that's what the issue is there. So I wonder if I made this borderless, if that would fix that. How do I do that? Border, window, borderless. See if that moves anything. That didn't move anything. Yeah, that didn't move. Can I still move this around? I cannot. Oh, that's doo-doo. Let's see. I still think that there's something there with that. I'm willing to investigate. Anyway, willing to investigate. See this blue line go straight through the center. Should all sense. It's not. Okay, I'm gonna move this over here. This will be my little research box. Okay. Why is it doing that? I'm getting viewport. This is for the raycast. Wait, so this raycast that I'm using now is... Okay, it's not even casting. Let me comment this stuff out. Comment. And throw a pass in here. So when I'm positioning this thing, upstairs right there. I'm getting the viewport rect dot size, and I'm positioning it. Is that even what I want to get? Get viewport rect returns the viewport's boundaries of rect 2. I would actually just like to get like the camera dimensions or something. Is that a thing I can do? See camera. Get camera, get make current projects, position, normal, perspective, unproject position, size. Are you serious? Hmm. Size. Size value, get size. The camera size measured as half the width or height, only applicable in orthogonal mode. Since keep aspect locks on axis, size sets the other axis size length. Only applicable in that. What's only applicable in that? This entire function or this section here? How am I supposed to know that? Since keep aspect locks on axis. Oh, okay. I think I know what that's talking about. Alright, so if I say dot size for that, let's see. On ready var cam dimensions. I don't know what that is yet. Oh no. Cam equals get node dot slash dot slash get node onReady cam equals yeah. I know what I'm doing. I know what I'm doing. I do things. Get node, and then up here we're gonna say export var cam path equals or cam node path, and then get node cam node path, and I think that would do it. Typeless export needs a constant expression assigned to infer type. 4-1. Is that because I have it? Whatever. I'll do it. So shut up. There we go. Cam node path. Cam node path. And then we got the cam, and then now we can say on ready var cam mentions equals cam dot size. That's what I said, right? Dot size. Yeah. What am I doing? Cam dot size. Okay, and then I want to print cam dimensions. I want to see if it's the right size that I'm expecting, and I don't know why I ran the entire project. Alright, so it's you can't you can't steep or brew green tea twice. I thought you could. Invalid get index size. Oh man, Jesus. Can I do get size? Trial and error. Cam dot get size. I doubt it. I doubt that's gonna work. Stop play scene. Oh, base null. Oh, I'm a dummy. I have to actually assign the camera to this. Huh? That would help, right? Oh, it says 1. Okay, so yeah, that wasn't what I was hoping for. So we reference the internet. Godot, how to get camera dimensions. I'm putting 3D dimensions, but I'm not actually meaning three-dimensional dimensions for the camera. Just so it does, I don't get a bunch of results for like Cam 2D. Orthogonal camera bounds, no. Get screen size bounds of 3D mesh, no. Camera, get out. I mean, it should be this. Where's it at? It's somewhere around here. Right here. Width, display window size width, sets the game's main viewport width on desktop platforms. This is the default window size. Stretch mode settings also use this as a reference when enabled. Resizable, borderless, full screen, always on top. What is test width? Greater than 0 overrides the window width when running the game, useful for testing stretch modes. Oh. Yeah, I mean, it should be that. Display window size width. Display window size width sets main viewport width. And that's pretty much what I did. Give viewport rect. Alright, so let me get rid of all this junk. That waste of time writing that. Don't need this anymore. Let's try. Actually, get viewport rect returns the viewport's boundaries. Is set as top level transform notification notices retrieve. Oh, this is canvas item. Oh wait, what? Oh wait, no, yeah, that should be right. Because I think I printed this before. I say print viewport dimensions. Oh, I spelled that wrong. Oh my god. Running scene. What's happening? Is it broken? I think it's broken. Let me try running it again. Maybe because I tried running it while I was saving. I don't know. Huh. That's weird. Is it this that's breaking it? There's only one way to find out. Oh god, what the hell did I do? What did I do? Broke things. I don't even know what I broke. Oh, I think I was playing third person character. Yeah, that's what I was doing. Okay. I was playing this scene, but I had the script open, so I didn't know. Alright, crosshair position. Let's try that again. Print, viewport dimensions. Let's see what we get. Yeah, 1024 by 600. It's exactly what it's supposed to be, I think. 4 by 600. So why is it that this is perfectly aligned with this, and somehow things are getting moved? What if let's see. This has a size right off the bat. It says 50/50, and it defaults to 50/50. So I can set the size. I can set the size myself, and because I have it on keep centered, it's gonna automatically put that in the center, and it's gonna automatically put that on the center based on, um, the width and height of this little texture here. Size, rect size, rect scale. That's what I'm using. Rect scale. So we have rect size and rect scale. Those pretty much are going to be doing the same thing. So what I'm doing here is I'm dividing by the multiplier for the viewport dimensions. I mean, for the rect size. I'm timesing by the multiplier for the rect scale. So if I were to try to visualize that and say whatever the dimensions are here, 1024 by 600, 1024 by 600. I think I can do math here. I'm doing divided by 0.15. Divided by 0.15. So it's like super huge. And then the scale, I'm doing same thing, right? Self.rect.scale times multiplier. So I'm taking. Oh, wait, what? Self.rect.scale times multiplier? Is that right? That don't seem right to me. Oh yeah, no, that's right. That's right. Yeah, because the scale is 1 to 1, and then I'm multiplying by 0.15 to shrink the scale by the same that I enlarged it by with the size. Um, yeah, so I think that's right. So if I take the scale and I times 0.15, yeah, that's right, and then times 0.15. Yeah, see, so it's perfect, perfectly centered. But for some reason, everything is shifted up elsewhere. Oh, I had green tea in it. That tea is amazing. Yeah, tastes so good. So I got to figure out why it's being moved, and I don't really know why it's being moved. Wait a second. These lines are like way down here, but it's showing them as if the camera's like this. Is it something I did somewhere? Oh my. You gotta be kidding me. It's been me this whole time. I had a vertical offset set like that. That's what's been tripping me up this entire time. Dude, I, I I've been stumped on this for a fat minute, trying to figure out what the hell is going on with this, why everything's all shifted weird and stuff. Like everything, even in here, everything's shifted weird, and I'm like, what's going on? Why is it shifted so weird? That's because I had a. Oh my god, that is ridiculous. I'm glad I figured that out though. I broke so many things trying to figure out what the problem was with that. Okay, multiplier didn't change anything. Let me run this and just make sure everything's still working good. If it's not, we'll investigate why. Hey, now it is exactly where it's supposed to. Oh my god, dude's got a whole mouth. He doesn't need a mouth. Yeah, look at that. That's, oh man, that's beautiful. So now, if I go back to my camera, turn my raycast back on, and run it again, but I need to move my camera. So camera pivot, initial Z. I think I disabled that in the code, so let me go re-enable that. Boom, boom. Enable raycast. Initial Z, initial X. I don't want to move it on the Y because it shouldn't have to be set. Oh man. I've been fighting this thing for so long. Yeah, dude, now everything is just looking beautifully. Okay, so now I can get rid of this ordeal. I was gonna use code to fire a raycast, but where's that? It should be in camera pivot. Oh yeah, here it is, physics process. Just make sure there's nothing else in there. There's nothing, and let's delete that. Okay, and what else do we need to do? We need to move the camera on. I think I had it at 0.75, I think, on the X. Let's see. That is awesome. Alright, I'm gonna get rid of that stupid cube. Q was just for debugging purposes. Third person, collision shape, I'm going to disable these. Okay, and this raycast is enabled. The running sideways thing is still looking kind of weird. But at least now where what the hell's going on with his head? At least now where I'm looking, I can actually, look where I want it to look. Wait, where's my little dot? Why is my little white dot not there? Little dot should be there. Yeah, 4 dots there. Should be there also. There we go. Yeah, now it's perfectly aligned. Oh man, that's so nice. Ah, dude. That's relieving. I had so many problems with that, and it was because of me the whole time. Typical, right? And look at the raycast. I can't even see the raycast, but you can see the shadow. I'm pointing at the screen, but no one can see it. But you can see the shadow on the wall. It's awesome. See the shadow of the raycast. Got him. I love it, man. Love it. Yeah, I gotta fix the animation stuff. I'm using like a simple state machine, but I think I want to use a something a little more not that. Okay, cool. Also, the head tracking. I want to change that to use uh, the like normal direction of the camera somehow. Um, right now, what I'm doing is that little blue ball is the bone that's in his head is just looking at it. So if I don't look at something that can collide with, it will he'll go looking back there. But I want to make it where he can look, all over, not just. And another problem that comes from that is this whole thing where he's looking up into the sky for whatever god awful reason. I have no idea why he's looking up there, but he's looking up there, so what can you do? Also, I tried making it do instead of like snapping to that rotation, trying to do a like a lerping kind of thing, but I failed last time. I want to try to do that again. Not the fail part, but fix it. Try to fix it. So that's what I'm gonna do now. Try to fix that head bone. So direction change on camera pivot, camera cast collision. This is where I do the whole bone thing, I think. Yeah, right here. So what I'm doing is I'm getting this T forward vector, which is, let's see. No, this is for the limit rotation. I'm getting this T, which is the bone pose, which I think is a transform. So I think I need to add that in there. Transform. And then, yeah, I think that's a transform. Let me check. Returns the pose transform of the specified bone. Yeah, it's pose transform. T equals T dot looking at. So looking at uses a transform and then get a vector and then an up direction. But I have this vector here. So I think I want to create a new variable. And then I want to linearly interpolate the x, y, and z of that vector to whatever value it's supposed to be from whatever value it's currently at. And I think that will kind of track the head to that direction instead of just going like, you know. All right, so skeleton head bone pose, post rotate look. I think it's supposed to say pose rotate. So let's see, make skeleton head bone pose rotate to look at this way. So what I wanted to do is I want to get this, extrapolate this out of here. I use the word extrapolate because, you know, I don't know why I use it, but I use it. So let's see, collide point. What can I call this? Camera, cast, collide point, transform, origin, cam, collide, vector is a vector 3 equals camcast collide point dot transform dot origin transform dot origin. Let's see, var x. Can I do this? I cannot. Var x equals this. Wait, actually, I already put it there. Why not just do this under here? Var x equals cam collide vector dot x. Var y equals cam collide vector dot y. Var z equals cam collide vector dot z. I don't know if this is gonna work. Oh wait, no, wait. Yeah, what I want is the, okay, so I think I know what I want. So I want to say var t dot looking at get bone pose t origin vector vector 3 equals t dot origin, because it's already a transform, and then this is going to say cx cy cz, and then I think I also want to get the tx or ty or tz equals t origin vector equals t origin vector equals t origin vector dot z dot y dot x. Then I can move this down here. Actually, we'll move these above these, and then when I'm grabbing this variable, I can say I can lerp these, lerp, lerp, and lerp. I don't know if I can lerp a whole vector, that's why I'm just doing the values. Lerp from tx to that cam collide vector x by 0.1. We might as well also make a our lerp amount equals 0.1, so that way we don't have to, if we wanted to change this, we don't have to change all of them. Lerp amount ty can collide vector y and by lerp amount, and then tz vector z by lerp amount. Okay, and then now we can say var to vector 3 equals a vector 3, and then we'll just pass in these C values. Naming conventions, or my namings aren't too great, but I get by. To vector, vector 3 up. Alright, we're gonna cross our fingers and hope that works. Yeah, we're gonna cross our fingers. Play it. See what happens. Let us see what happens. I don't think that worked. Lerp amount, and here's exactly what I was talking about. 0.01, where I only have to change one value instead of a bunch of them. Yeah, that's definitely not doing what I was hoping for. That's weird because am I just getting confused about the linear interpolation? Oh, I can pass vectors. Oh my god, that would have made things so much easier if I'd have known that. I should have looked. Don't even need all this. And then this is going to be a lerp t origin vector to cam collide vector by 0.1. That's cool. Oh, I should have done lerp amount. I mean, it doesn't really matter now because I only have one. T equals t dot looking at -2 vector, vector 3 up. Where am I assigning t back to? There we go, right here. Skeleton, set bone pose, head bone index, t, resting pose, set bone pose, head bone index, resting pose. This is going to be the same thing as what I just did. I just broke down the vector and then reconstructed it. So, I mean, this isn't going to work either, which is a shame. I just don't understand why. That is bizarre. Set bone pose T. I mean, if it's taking T's transform and changing it to look at this new vector that I had, if the vector's like half of the vector that it's supposed to be, and it looks at that and then it sets the pose, it should interpolate by that. Like that should work. I don't understand what I'm missing. I'm missing something, just not getting it. Just not getting it. What am I missing? Hmm. I mean, do I need to instead of doing this, do I need to lerp down here? Say set bone pose lerp from T origin vector. Oh wait, T. T is one of them. T dot looking at T is a transform. I don't think I can lerp a transform, can I? But I also don't have a transform. Var init T, or we'll just var T temp equals T. And then we'll just say pre-T equals T. And then down here, maybe I'll try it. I'm not against trying it. Lerp from pre-T to T by 0.1. I'm not against trying it. Yeah, I didn't think so. Can I convert argument 1 from transform to float? That's because this doesn't support transforms. So that's what I was trying. I was trying to lerp the origin and then have that be affected um, by the looking at function there. That's what I was trying to do. I mean, the only other thing that I can try that I know of is to just lerp here too. And then instead of trying to store it in a variable, I don't know, maybe there's some weird thing that happens. I have no idea, but I doubt it. But you never know. If you don't try, you don't know, I guess. Yeah, I didn't think that would work. I mean, if that would have worked, I would have been fine with it, like going back to its resting pose like that. But it's just not. It's just not my thing. So now what I can do, what I can try, is let me just undo all of this because that did nothing. Undo all of this. Alright. Just make sure that I didn't break anything. I have a bad problem with breaking things and then like breaking things and then moving on, like continuing on and not checking if I broke anything and then I don't even know what I broke. Okay, so it's back to the same old, same old. Okay, so so what I'm doing now is I'm getting this collision point. Can I just pass and then it not throw an error? Will that work? Nope. Still work. Pass did not do it. So I gotta return. Return. I just don't want it to throw an error. If that works without it throwing an error, that's, cool. I don't see why it would, but usually Lintage just catch that and make a big deal about it. Yay, okay. Alright, let's see. So, instead of doing that, we're going to go into physics process here. And, oh no, on camera pivot direction change. That's what we want. So, because we already have the forward normal of the camera, the forward direction is equal to z. I can just use that and do the same thing here. And I'm wondering if I can just use like a rotation method on the bone to just rotate it the amount of degrees that it needs to rotate. That's what the looking at thing does. But the looking at, let me read the looking at stuff here. Returns a copy of the transform rotated such that its negative z-axis points towards the target position. The transform will first be rotated around a given up vector and then fully aligned to the target by a further rotation around an axis perpendicular to both the target and the up vectors. Operations take place in global space. So, the target vector is a vector is just an arrow that points out a direction with a given magnitude. The magnitude is, you can think of it as like how far away the end of the arrow is, the little triangle part of the arrow is from the beginning point of the arrow. So if I get a normalized vector, it's going to be less than 1, but it's still going to have a direction. And I'm wondering if I get the normalized kind of direction that the camera's facing and use the looking at function on the bone like I'm doing now, I wonder if that would still work the same. Cameras out of focus. Still work the same as it is now. I don't know. I don't know. But what would I be if I didn't try? So I'm gonna try. And I'm sure it's probably pretty quiet here, so I'm gonna turn on some music because it's just weird just not hearing anything. Go to my music, play that. Jesus. There we go. Got a little bit of music going. It's better than nothing, I guess. Turn my headset down a little bit. Okay, so I guess we'll do that now. So we got this looking at. So we need to do the same thing. I'm gonna get this bone pose from the head bone index, and then so let's go ahead and just grab that. Get the skeleton's head bone. So we got T forward, just T.base.z, player forward, player head angle. We already got Z here. T is a transform. So we want to look at that by vector 3. I mean, I think that's pretty much it. T equals T dot looking at Z. Does normalized return a I think it sets it. I don't think it returns it. Are you gonna take me to it? Jeez. Normalized. Oh, just showed something. Vector math normalization, A dot normalized. A equals A dot normalized. Also, I didn't even do that here. X equals X dot normalized. Z equals Z dot normalized. Okay. So here's where I was doing it. Looking at Z vector 3 dot up. Make bone transform. Look at, and then make bone pose change to new T. Right, and then we say skeleton dot set bone pose head bone index T. Oh. Skeleton set bone pose head bone index T. I don't know if this is gonna work, but it's worth a shot. dude. Oh, dude, that is amazing. And there was so much less code. Except I can do this again. Yep, that was way better. There's a theory. I put it into practice. Boom. Magic, baby, magic! Okay, let's go back to our scripts here. Yeah, so this whole thing I can just completely get rid of. Except for this. Need this. And then this. Need to shift tab. Get the forward vector of head bone and the forward vector of the player. Then get the dot product angle between the two. So T forward. So we still need that. Player forward, we don't need... Yeah, we do need the player forward because we want to get where he's standing, how far his head is turned. So we need his body's forward. And then we do the calculation based on where his head's facing and then get the angle between. Player head angle equals T forward dot product player forward. That just calculates that angle. So if his character's pointing this way and his head is turned this way, the angle between these two is what that dot product is, or this dot thingy, whatever, is calculating. And then it returns a float, so it'd be like between -1 and 1, I think. And then I just check. I field tested what the values are, you know, based on his stuff, and I saw that 0.4 was kind of a decent range, so I just used 0.4, and then if it's greater than or equal to 0.4, which would be him facing this way, straight forward is 1, and then it goes 0.4 this way, and then it goes 0.4 this way, which is weird. I guess it's like, I don't know. I don't know why it's 0.4, 0.4. It's not negative 0.4 and 0.4, but or 0.4 and then greater than 1. Well, I guess because it goes from -1 to 1. Anyway, I don't know. Whatever. Anyway, 0.4. So when he's anywhere between 0.4, he can turn his head, and then if he goes less than 0.4, like his head's turning too far that way, he stops, and then I have this resting pose saved to where it'll stay in that pose even though you're looking farther back that way. So that's that part. Player head angle, so that should be pretty good. I just need to change these comments. Get the forward vector of the head bone and the forward vector of the player, then get the... Oh, no, that's right. Allow the player to head to rotate only. So I need to get rid of this set bone pose. And I also need the wherever resting pose is. Oh, right here, resting pose equals T. And this is updated every time the character is turns his head at all. Any direction. Every time he turns his head, it updates. Oh, I already have it right there. Okay. Resting pose equals T, but I need the actual variable here. Where's this at? Is it up here? Okay, so I put it up there. Cool. Alright, so I can get rid of all of this. I can get rid of all of this. Looking at, I can get rid of all of this. Get the skeleton head bone pose. I can get rid of that. Collision point, cam cast, collide point not visible is true. Alright, now I can save that function for a another task. That's pretty cool. That was easy. That was an easy thing to do. happy about that. Very happy. Just double check, make sure everything's still working good. Head turns, turns only that far, turns only that far. Head does that. Head looks down. Look at that. He only looks so far down. That is awesome, dude. That is amazing. Now I need to get this whole rotation thing figured out because, like, it rotating this way is, and being able to rotate under is a little much. So I gotta figure out how to clamp that. I need to clamp those values. So that's what I'm doing next. So we have this camera pivot here. We've got this camera. We got this. We got the script. And where I'm doing the rotation is in the process. Probably not a good idea to do the camera rotation in process, but whatever. Oh no, I'm doing it in unhandled input. I'm doing it anytime there's an input from the mouse. That's what I'm doing. This I can get rid of. This. Camera.field of view equals default cam field of view. Yeah, we don't need that. So we're doing that there. And then on player position changed. So right here, event is input event mouse motion, self.rotate, object local, vector 1, 0, 0, X. So this is rotating on the X-axis by X degrees or whatever, radians or whatever. But I need a way to clamp this rotation. Rotate object local, rotate Y. I mean, I guess what I need to do is print what the camera rotation is beforehand and then just see what we're getting. And then based on that, the type of values that we're getting, I can determine how to constrain the rotation. So we got print. What is this? Y rotation. Y rotation. And then camera dot get. Is there like a rotation? Property rotation degrees. I don't know if that's what I need, but that's what we're doing. That's what we're doing. And then we got this. This is a X. So X rotation and camera dot rotate degrees. Okay. Let's play it and see what happens. Okay, so it's saying 180. Oh, duh, because I'm not supposed to get the rotation for the camera. I'm supposed to get the rotation for the camera pivot. Because I'm doing self.rotate on both of these. So that's the problem. Not camera.rotation degrees, self.rotation degrees. Self.rotation degrees. Now let's run it. There we go, that's better. Okay. So, what I'm seeing is 0, 0 is about right here. So 0, 0 is about right there, which is cool. If I move about here, so we got X, we want this to only be able to go like, I don't know, 50 degrees. And then if I go down, how far down can I look? About 50 degrees there too. So the thing I'm thinking about here is I want to get like an absolute angle. So I want to say if, yeah, so I think I know what I want to say. So this is X rotation, Y rotation, whichever one that is. I don't even know which one that is. That is self.rotate degrees. So our current rotation equals self.rotation degrees. We'll just put this up here. Current rotation, and then what we want to do is say something like if this is rotating Y, rotate Y on the mouse X position, so that's rotating this way. So we don't want to do it here yet because that's not what we've tested. We want to do it down here. So we want to say if current rotation dot X we could probably do something like if negative 50 is less than current rotation is less than 50. Self.rotate object. So if as long as current rotation dot X is in between these two numbers, self.rotate object local, yada yada. If it's greater than those, then don't do that. Let's see if that fixes our neck break problem. Invalid operands bool and int in operator less than. Invalid operands bool and int in operator less than. If negative 50 is less than current rotation dot X is less than 50. What the hell? Do I have to say and current rotation is less than negative 50 is less than 50? Maybe it's a syntax thing. The little error outputs aren't too descriptive. Invalid operands vector 3 and int in operator less than. Wait, what? No way. Vector 3 my ass. Oh, no, you're right. My bad, sorry. My bad, dude. Has it been playing the same thing on loop this entire time? No? Feels like it has. There we go. Let's see. Down. Oh! Ah, shoot. Hey, it won't let me go back up. Yeah, so I didn't see that coming. I didn't see that coming at all. Oh my god, it is playing this on loop. Shuffle all. There we go. I need to get some more music. Let's try this. Okay, so obviously in order to get an up and down, these need to be negative and positive numbers, I think. So let me X. Let me print X also. I'm gonna get rid of this. It's not getting in the way of our data. Okay, yeah, so it's negative. So positive is down, negative is up. So what we want to do is say if negative 50 is less than current rotation dot x, and x is less than 0, x is greater than 0, I think. Then do that. And take this. Say LF that. Get rid of that and. Less than 50, and x is less than 0. Worst case, I just gotta flip those less than or greater than things. Oh, it didn't work. Oh, it did. It just it locked me there. Damn. Okay. So what happened? It's less than 0. Greater than 0. There we go. Yep. I knew that's all I needed to do. Cool, cool, cool. Oh no! Ah, something I didn't consider. His head's all jacked up. Man. Okay, but I had to fix that with because I did a similar thing with hold on one second. I did a similar thing with this thing, forward direction, side direction. Yeah, but it's using move and slide. Move and slide just takes as like a direction vector. This look at is taking an actual uh, what's up, Greg? It's taking an actual, like, let me think about this. So on camera pivot direction changed. It's a new direction. It's coming from the basis vectors for the actual camera, not the camera's pivot. Direction changed, yeah, cam facing. So my question is, yeah, Godot's nice, I like it. I would like to use, because right now I write in GD script, and I would like to use C# because C# is more of a, you know, an actual language than GD script. And plus it could carry over in other areas too, obviously. But it's just GD script is so close to Python, and I know Python so well, it was just so easy to pick up. So when I turn this way, it just breaks completely. Yeah, you can use C# in Godot. Godot, however you pronounce it. I just haven't done it. I don't understand why that's breaking it. Works fine when I face this direction, but when I face this direction, it breaks it completely. Yeah, it's almost identical. It's like, I mean, it's got this is changed, and you don't have to reference like self all the time, although I do in places. You'll see like I have self. I don't have to do that. I could just say rotate Y and it's exactly the same thing. And then also putting var in front of it. And yeah, that's pretty much it, I think. Other than these exports things, those are obviously for the engine. But yeah, that's, I mean, it's almost identical to Python. So yeah, it was pretty easy to pick up. So the basis vector for the z-axis for the camera is facing this direction. When I turn, it's facing. You should do some Blender scripting. That's all Python. Yeah, I thought about it, but it's a lot of like math and stuff, and I'm not real good at all that. I'm good enough to get by with this stuff, but like for example, like people make, you know, tools for these and stuff. Like, I don't know, like for example, if you were to create a plane and then use the code to like do stuff with the plane, make stuff where you can, you know, shape the plane however you want it, dealing with all like the vertices and stuff, that stuff gets pretty crazy. Like the matrix math, I guess is what it would be called. It's like dealing with all these, you know, matrices, whatever, and manipulating those. That's where things get hairy for me. Yeah, it's crazy, man. It's complex. right now I'm trying to figure out this whole look in the same direction as my camera thing. And before I was using a raycast to get a transform of, you know, where it's hitting, and I was using that to make the bone in the head look in that direction. And I changed it now to where it just looks in the direction that the camera's facing. But the issue that I'm having now is when I turn this way, it's like it's based off of this global direction. So when I turn this way, it's doing some weird stuff. I don't know. Works fine this way, just not, you know, any other direction. So that's what I'm working on now. I'm good at what I know. I just don't know much when you start getting fancy. Yeah, I feel you on that. Let's see. So yeah, maybe with like the Euler angles or whatever. Oh, I see. Okay. Well, when I play it, when it plays, when I play it, you know, like it works fine, and then when I turn this way, the head stays in that direction. That might be because of my resting pose thing, but it's like I don't know, it's hard for me to explain. It's like globally it's looking in this direction, and then when I turn the body in this direction, the rotations are still based on its local coordinates. So that's why you see if I turn too far this way, its head stops rotating that way, because I have like a sort of clamp kind of thing on there. But it's only working from this point all the way around to this point globally, but working fine locally. But I think it might be a local issue. Yeah, exactly. So when I turn the body, that should also turn with it, so that it does the same thing this way. Looking at returns copy transform rotated. Ah, look, operations take place in global space. Setup local to scene, viewport texture, path to node is invalid. That's not good, no. I don't know where that's coming from. Scene main viewport. I don't know where that's coming from. No idea. Oh, that's not. Oh, that was something else. Okay, let's see. Why? The question is why? Because looking at is global. That's right. Rotates the transform. Oftentimes I don't even know what I'm looking for until I find it. I'm trying to look for something that'll help me avoid having to do a lot of complex stuff. I have a habit of going straight for the complex stuff when there's an easier solution. And I've been kind of forcing myself to get away from that. X-form. What does X-form do? Transforms the given vector 3 by this transform. Is there not like a look at function or constraint? Yeah, there is. That's the one that's tripping me up because it takes place in global space. And that's where I'm getting that issue where when I turn the body, it's still using the global, like, front half of the scene 180 degrees around. I think that's what my issue is. Because my camera pivot here is rotating locally on this axis. And then I'm trying to get the forward vector of the camera and then applying it to the head bone using a global method. I think that's where it's getting mixed up. Yeah. Yeah, I'm still getting used to the whole vector rotation stuff. I'm just surprised I got it as far as I did. Very surprised. I just stare at it until a solution comes to mind. So how can I do it? Thanks. What I'm really interested in is, I doubt it. What I'm really interested in is the procedural animation stuff. That stuff's pretty cool. But I'm having issues with inverse kinematics with Godot, whatever it's pronounced as, with the rig that I have. The character rig that I have. It just breaks everything. Rotation. There's some neat Unity stuff that works with AI to help things learn how to walk and all that. Again, above my brain. Oh yeah, Unity's crazy. I see all kinds of stuff in Unity. I see a lot of people, they do like what you said with the AI and stuff, and they'll have like little robots in the game engine, and then it's just like learning how to do its own thing and walking around and shooting stuff by itself and using AI. It's pretty cool. It's amazing. And watching your stream today, even Unity's like what's it called? It's slipping my mind right now. The word's like right there. When things fall, I feel like an idiot. When things fall and move stuff, what's that called? Geez, why can I not think of the word for that? Oh my goodness. Physics engine. Jesus. Unity's physics engine is, yeah, physics and clouds. Unity's physics engine is pretty nice. Just looking at the way those cubes just interact with each other, it's really nice. I don't think this physics engine is as good. I haven't really done a lot with the rigid bodies and stuff though. With the kinematic body, I'm sure it's probably the same in Unity. I have to kind of do my own physics. What am I looking for? Oh yeah, rotation. 2D, don't want 2D. See, I'm afraid I'm gonna have to do this whole quaternion stuff and all that. That's what I don't want to do. I wonder if I could, you know what, I want to see what the difference is between my bone basis angle and the camera basis angle. Because if I can do that directly, then I'd just rather do that. Get it over with. Let's see, this is the bone you're looking at. So I'll just print it right here. Oh, here we go. T forward. Print T forward. Let's call this bone Z basis. Bone Z basis. I have another print that's happening. I want to get rid of that. And then the camera Z. I don't have that. There's an X, a Y. Yeah, okay, yeah. So, wait. Current rotation. I thought I had that somewhere. Cam facing, here it is. Basis. Print. Cam facing dot Z. Camera Z basis. Printing a little too fast, but whatever. Bone Z basis 7, camera Z basis, and then now, oh no, 0.9, and then now when I rotate just the camera, they're still about the same, and then I keep rotating the camera. They're still about the same. One's 862 and one is... Wait, are they both the exact same thing? Did I print the same thing but twice? Camera Z basis. This is camera global transform dot basis. Oh, I have global transformer here. What? Oh, my stuff is just a big mess. T.basis, get bone pose. Why are these the same? Because the bone should stop rotating. It should not be the same. Like they're the exact same. Okay, let's try it and then turn the character and see what happens. That's weird. It's still the same. Yeah, that's real bizarre. Global transform. What's the difference between global transform and regular transform? Global transform. World space global transformed by this node. Euler angles. Yeah. Yeah, I would imagine if this says global, then just regular transform would probably be local. Let's see, can I find that? Transform, transform. Transform. Boom. Local space transform of this node. Okay. So let's try transform. I thought I was already using local space for that. Oh, well that doesn't make sense because I'm rotating the pivot point. The local would still be exactly the same number every time. So that wouldn't have fixed that. So global is what I need then. Global transform. So then my issue is rotating. What is my issue then? I'm back at square one, man. Okay, so I'm rotating the camera. I'm getting the cameras facing Z vector, forward vector, globally, which makes sense. And then I want to rotate the head bone locally. Alright, Greg, take it easy, man. Thanks for stopping by. Locally in the same direction that, and that's what the look at was doing globally. But initially it was looking at, when in doubt, draw it out on a piece of paper. Yeah, I probably need to do that, to be honest. Let me find a piece of paper. Because I need to visualize this. Okay, so body's facing that way. Camera is facing this way. I'm getting the helps to write out logic flow or what you want to do. Yeah, I'm drawing it out. That's a good idea. And then the head bone is facing this way. This is a global rotation, and this is a global vector. But I'm rotating the head locally here. This much. It's local. That's what I do when I've been banging my head against it for a while, but good luck. Thanks, man, I appreciate it. Global, local. So I think what I need to do is get I need to figure out what direction this global is facing relative to this local vector. How in the world did I even do that? Probably gonna have to do some Googling. Global vector to local. Translate a vector from global space to local vector in 3JS. That's a JavaScript thing, but who knows, maybe they have some math in there somewhere. Unity. Let's check out Unity, see if they got some math in there. Alright. That's not going to help me. Transform vector. Local global vectors to improve. I guess I'll add Godot to that. How do I get local space vectors? I mean, maybe I'm just thinking about this all wrong. It's possible. Very, very possible. Need an actual example for global to local space transform. Position, world, global coordinates into object local coordinates. Did not work. Lovely. Now there are two local and two global methods which are used for that purpose. Are you serious? Really? What? Two local? Is that a thing? Let's check it out. Let's see. Two local. Node 2D spatial. Why did I click that? That's not even what I wanted. Methods. Oh yeah, right there. Two local. What? Transforms global point from world space to this node's from this node's local space. From this node's local space. Transforms global point from world space to this node's local space. How would that benefit my use case? Or would it be better to change my headbones local to global and then get the angle between the global z vector for that and the global z vector for the camera's z vector, get the angle between those, and then rotate the head based on that angle? I think that's what I'm going to do. Or at least that's what I'm going to try. So let's, so what do we have here? We have this new direction. This is coming from the camera. Let's see. T, this is the bone pose. T dot looking at. So what I want is, here's the forward. And it takes in a vector, doesn't it? Yeah, vector 3. This is 2 global. So T forward. I'll just put it under here. Bar T global equals T dot basis dot Z dot to global. Is that right? Isn't declared on base vector 3. Or is this? This might be a spatial. Interesting. Get bone poses a transform. I get the basis, the z vector, and then I convert that to global. Then it says 2 global isn't declared on this vector 3. Oh. Duh. Oh my god, I'm an idiot. Would help if I had a slight hint of intelligence. 2 global. T global equals 2 global. That's not confusing at all. T.basis.z. 2 global, and I'm curious what that's going to be. So let's. This is the bone z global. T global. Bone z global. Okay, let's look at these numbers. Bone z global, -1, yada yada yada. Bone z basis. Cam z basis. And then I rotated. Yeah, that's still not right. Man. Still not right at all. 2 global. Maybe I'm not supposed to rotate the bone on its local. I don't know. Maybe I need to rotate it globally. Can I even do that? I have no idea. No idea what I'm doing. Get bone pose. Well, looking at does rotate it globally, so that's not even an issue. So why is it giving me that problem? I mean, it's correct, because if this is forward and I go 90 degrees over, his head turns 90 degrees. But I don't want that. You know what? You know what my problem probably is? Maybe I just need to get the angle that his body's facing, and then just figure out the angle between, instead of trying to do his head, figure out the angle between, yeah, but then that'll only work for left and right. Then I won't have the whole up and down. Well, I guess I could do the same thing, just get the angle, get the vector pointing forward, and then get the cameras, like, whatever, up and down vector. Whatever it is, the X or Y, whichever one that is. Or no, Y is this, so X or Z. Because then Yeah, because then I should be able to get the angle and then just rotate the head bone on that angle. And then that should work, I think. So let me think about this. So if the body's facing forward and the camera's turned this way, globally, if the body's facing this direction and the camera turns this way globally, then I get the angle that rotation occurs, like the angle between, you know, pretty much where this ball is to where the white dot is, and then just rotate the head based on that angle. Would that work? Would that be a solution that could actually possibly work? So let me get rid of all these prints because I don't need these anymore. Get rid of that print. There should be one more print somewhere. Maybe not. Okay, so we got the direction change of the camera. We're on the third-person character controller, or the third-person character, whatever. We have the Z, and that's global. I should make note that this is a transform. I think I can do this. Can I not do that? Oh, I guess I can't do that. Anyway, so I have the Z. I don't know why I have it normalized here because this is a basis vector. It's already normalized. So I don't even need that. I'm pretty sure. Let me double check. Cam facing, yeah, basis. It's already normalized. Just stupid. Let's see. Get bone pose. This bone pose is happening. Returns the pose transformed. Specified bone pose is applied on top of the custom pose, which is applied on top of the rest pose. Oh, I just said I don't need to worry about that. So I need to get this kinematic bodies forward. I could probably just use this player origin thing here because this is always pointing that way. That'd probably be easier to read anyway. I don't know. Get skeleton head bone pose. Vector. Do I have that reference player origin? Yeah, I do. Player forward vector equals player origin dot global transform dot basis. This is going to be a vector 3. Alright, so player forward vector, and then I also have the cameras forward, which is this Z. I want to get the dot product between those. So I guess I'll do that here. Forward and Z forward, or cam forward, angle offset. Then that would be var body to cam angle, yeah, angle equals, this is going to be a float probably, equals Z dot player forward vector, body to cam angle, and then instead of doing this looking at, maybe I could say t equals t dot rotated vector 3 dot up by body to cam angle. Vector 3 dot up, because I didn't invoke it. Invalid index up, it's because that needs to be capitalized. Oh, maybe it is supposed to be like that. Vector 3 dot up. There we go, yeah. Okay, cool. Rotated vector 3 dot up, body gap. So that should help it rotate left and right, I believe. T equals T dot rotated, I think. I hope so. Let's see. Basis to a variable of type vector 3. Trying to assign value of type basis to a variable of type vector 3. Wait, where? Oh, duh. This is because this needs to be dot Z. That would be a problem. So what just happened now is not necessarily a bad thing. No matter which way I turn, he seems to always be looking in the same direction. And it's inverted. But no matter which direction I turn, it's doing the same thing. And that's great news. The reason that's great news is because that means it worked. That's why it's great news. That's why it's great news. Now for this, I would just need to get the inverse of that, and it will turn with the camera, but it's still going to have some weird like offset. Where I'm looking forward, it's going to be looking off to the side just a little bit, I think. Oh, now it's what? weird. Oh, now it's like way over there. Huh. Okay, so I lied to you on that. So what's the issue? Rotated takes what? Phi, I don't know what phi is. Rotates the transformer on a given axis by a given angle in radians. Using matrix multiplication, the axis must be a normalized vector. Okay, what does dot give us? It gives us an angle, but in what? Dot product. Dot product is one of the most important concepts in vector math, but is often misunderstood. Dot product is an operation on two vectors that returns a scalar. Unlike a vector which contains both magnitude and direction, a scalar value has only magnitude. The formula for dot product takes two common forms, that and that. However, in most cases, the easiest to use built-in method. Note that the order of the two vectors does not matter. And then it gives us this angle. The dot product is most useful when used with unit vectors. Making the first formula reduce to cos O, this means we can use the dot product to tell us something about the angle between two vectors. When using unit vectors, the result will always be -1 to 1. We can use this fact to yada yada yada. AP equals A dot direction 2, AP dot FA. Okay, so it gives us an angle. We know that. It's always between 180 and 0. But, and it converts it to, so I need to convert this angle I have to radians, I guess, is what needs to happen. Is there a method to do that? Radians. Alright, I'm gonna see if there's a function called something like 2 radians or something. 2 radians. To convert degrees to radians. Alright, so I know to convert degrees to radians, use deg to rad. So where I rotate this, I need to say deg to rad, and then pass in my degree right there. And I gotta be right back. I gotta take a leak. Alright, I'm back. I hope that works. Degrees to Radians. That may be the key. And nothing happens. Nothing happens. That's fantastic. Z dot player forward vector. Print body cam to angle, dag to rad, body cam to angle. That's interesting. It said the dot is going to give me the angles in degrees. 90. But it doesn't. Or at least I guess I assumed. Unless otherwise rotated. Look at this global. What if I used well, the deal is so what am I trying to do again? So for example, I go to top view. For example, I have the player here. This is looking this way. this is looking this way. If the camera is looking this way, this is looking this way. If the camera's looking this way, player forward direction, player origin, global transform.basis.z, and then camera direction, which is a global transform, z. Body to cam angle, z dot dot, player forward vector. And that gave me... Oh, I'm so stupid. Oh my god. It said, if I go back to the thing with here, it said when using unit vectors, the result will always be between -1 and 1, 180 and 0. I'm so stupid. I can't do a deg to rad on this because, let's see, is there like a map function on here where I can map those values? Which typically means this parallel pattern. These guys don't even know what the map does. Oh, this guy's a genius, huh? That question above, it doesn't work like that. You don't come up with the random stuff and ask, okay, explain to me why not. You have to explain. Well, for this exact use case, I have a -1 to 1, right? And it maps to 180 and 0. Well, you could give it a range, -1 to 1, and make it 180 to 0. And this guy's used processing, so he knows exactly what he's talking about. These guys haven't, so they think it's a linear interpolation when it's not. I mean, it's not difficult to implement, I just... Dude, this dude's being an asshole. Okay. I just wanted to read that. So what I want to do is map algorithm. Mapping algorithm. This is not what I was looking for. I think I know what I could do. Yeah, I think I know what I could do. So, let's see. I can go to this thing called, what's it called? Code something. Life of, no. Nature of code. That's what it's called. Nature of code. Right here. Nature of code. Wait, no, not nature of code. p5.js. There we go. And then go to download. And then we want, what do we want? p5.js. I didn't want to download it really, but okay. Open. No, I want to like read it. Can I do that? Downloads p5. There we go. And now I want to find map. That's too many. Map brace. At map. function map. Prototype.map. There we go. So this is the function I'm looking for. Right here. That's the one I'm going to implement. And I'm going to call it not what they call it. They just call it map. I'm going to call it map range. So let's create a new function down here. Func map range. And then it's going to take a, say, x1, x2, y1, y2. Then there's this within bounds. I don't know what that means, but within bounds. Yeah, I don't know what that means, but we're not going to implement that. And then we can return. This should return, I think. I can do this. Float. Map range. Return in minus start 1. Oh, and then in, then it takes in the value. So it takes a value, maps it from this range, this beginning to that end. Or no, it takes a value, it maps it from what the value's current range is to what the value's end range is, or vice versa. I'll have to leave a note in there because that's going to get confusing. So the way that this works is you take value, you subtract from x1, you divide that by y1 minus x1, and you multiply that by y2 minus x2, and then you add x1 or y1. That's a little confusing. So I think this should say x1, y1, x2, y2. And then let me change these to reflect that accordingly. So x1, y1, x1 times y2, x2 plus. Wait, how did that end up being the exact same thing? Something's wrong about that. Divided by times plus divided by that times that plus. Alright, so we got value minus x1, because that's start 1, divided by stop 1, so that's y1 minus start 1, it's x1, times stop 2, so that's y2, minus start 2, that's x2, plus start 2, plus x2. Okay. Return that. So that should be it for that. So I should be able to call map range and then give those values. On this body to cam angle, float z dot dot, and then map range, like that, and then player forward vector, and then we map it from, what was it, -1 1, -1 1, map it from -1 1 to 180 0. And you know what? I would actually prefer if this function was... Nah, forget it. That's fine. Actually, you know what? Yeah, I'm going to do this. Start array list array. Can I not give types? GD script parameter typing. Static typing, that's what it's called. Reference item amount int. So how would I do a list? What would that be called here? Oh, array, capital array. Oh my god, it was right there in front of me and I didn't even see it. Array. End array. Right. I can't define a size, can I? I don't think I can give it a size. Value start null in array. I don't like that. I'd like to like specify a size, but is there a len? If start, I don't know if len is the correct. If len start or if len start is greater than 2, or end, or len end is greater than 2. Turn null. But it's got to return a float. Yeah, I'm just overcomplicating things. It doesn't need to happen like that. That's fine. That'll do just fine. It'll do just fine. Alright, so we've got that. Float, map range, player, forward vector, that. Okay. Let's play it and see what happens. It's possible I could have those flipped. Vector 3 and int in operator. Invalid operands, vector 3 and int. Oh, player forward vector. Wait, that's... Ah, that is. Because I did that wrong, like an idiot. Player forward vector, map range doesn't need to be there. This needs to say body to cam angle equals map range body to cam angle from -1 to 1 and 180 to 0. Now let's run it. Body to cam angle. That says 180 and 3.14. He's not liking something about this. Uh, 46. Wait, I mean that looked like it looked like it mapped, right? Let's see, 170, 0. Yeah, that mapped, right? This is 180. Degrees to radians. I should have put a space between these because I don't know what. Don't know what's happening there. So body cam to angle is the one that's -1 is 180 and 1 is 0. Yeah. So we're at 180. Right. 3.14 is that. Huh. Interesting. Very interesting, because that is seemingly doing what it's supposed to do. Numbers wise. T dot rotated. Vector 3 up, body to cam angle. What if I just T dot rotated? Don't care about all that stuff right now. We just want to skeleton dot set bone pose head bone index T. T equals T dot rotated. Body cam angle. Oh, okay, yeah, that's why. Got you. Body to cam angle equals deg 2 rad body to cam angle. I'm like manipulating the exact same variable each time, but that's fine. Yeah, so that's the problem. I wasn't updating it. I was just mapping it to 180 degree range, and that was it. Yay! Oh, dang it. T dot rotated. Invert it. It didn't look like it was exactly the way I would have liked it. I wonder why they took me off Facebook. Probably because of the music. Say that. Weird. Maybe it's this 180 to 0, -1 to 1. Yeah, no, that is not right at all. Just the way I had it was perfect. But the issue, actually, yeah, no. So when I'm facing forward, it's saying that it's 180 degrees. That's not right. Yeah, it's saying that that's 180 degrees, which makes sense because if I was facing this way and I turned all the way around, it'd be 180 degrees. And then when I turn this way, it's 180 degrees. So that's actually working, right? Except the head keeps turning, rotating the same direction. Like that. Which isn't good. But what I gotta do here is body to cam angle minus equals 180. So that 180 needs to be facing that direction. Just like that. That rotates that way, and then that's going to rotate that way again. So how do I tell it? See, that's 180. Maybe I can multiply it by let's see, so this is degrees to rad, body to cam angle. So we don't care about that now because we know that's working. What we want to get is the dot. Let's see what that is. Temp. If this will be... Oh, wait a second. Wait a second, that doesn't even matter because the dot product here. Oh wait, yeah, the dot product does negative to positive. Yeah, so the temp should do that. So why didn't... -1, that's negative all of that. Oh, it becomes positive at this point. So it's, this is -1, and then this starts positive. So I need to offset this by something. I need to offset it by 0.5, I think. because that's 1, and then this is... That's a whole 1. I need to offset it by 1. So if I did temp minus 1, I don't think that's going to work. I want it to be... Because if I'm looking in this direction, for some reason it's saying that it's -1. And then I look over that way and it's 0. And then behind me is... Oh, so I just need to invert it? No. 0 should be in front of me. So what, instead of it being from... How would I do that? I need to rotate. Am I gonna have to rotate Z and rotate the player? By 90 degrees? Let's see, that's probably what I'm gonna have to do. Z equals Z temp equals Z dot rotate Z. Wait, maybe I'm doing this wrong. The dot product is supposed to find an angle between two vectors, right? And it's always 180 to 0 or -1 to 1. In front of me is all -1. I only need to offset it by, but I can't just subtract it, can I? Or all I need is 0 to be in front of me. I don't care how far it goes in whichever direction, I don't think. So, what if I did? What if I temp equals temp plus 1. So that should give me 0 because -1's in front of me. Now it's going from 0 to 1. Oh, it's going almost to 2. So I lost the negative completely. And I gained a... Sometimes I don't know what the hell I'm even doing. Alright, so 0 is right there. We got positive numbers. We got negative numbers. Oh, when I try to offset it like that, it's messing everything up. Oh, cross product. Operation on two vectors, however, the result of the cross product is a vector with a direction that is perpendicular to both. Its magnitude depends on their relative angle. Two vectors are parallel. The result of their cross products will be a null vector. So the cross product would give me a vector pointing in the opposite direction, or in the perpendicular direction of a vector. Right? So let's see, if I want if I want the Z, I'm trying to think. I don't think the dot product is what I'm needing. I'm needing this, but I'm needing this to be 0 so that this is negative and this is positive. So that way when I pass the angle to the rotate function, it knows which direction to rotate. Right now the issue is this is -1 for some reason, but this is -1 and this is, it goes from 0 all the way to, you know, and I don't know how to rotate that. And then he's saying, they're saying to look at the cross product. Dot x1 times x2 plus y1 y2 dot product between x1 y1 and x2 y2 that x1 y2 minus angle equals a tan 2 det dot a tan yx or a tan. Oh, that's 2D case, 3D case. In 3D, two arbitrary place vectors define their own axis of rotation, perpendicular to both. That axis of rotation does not come with a fixed orientation, which means that you cannot uniquely fix the direction of the angle of rotation either. One common convention is to let angles be always positive and to orient the axis in such a way that it fits a positive angle. In this case, the dot product of the normalized vectors is enough to compute angles. Dot that. Lin SQ1 equals that. Lin SQ2 equals that. Angle equals A cos dot square root lin. So 3D case. In 3D, two arbitrarily placed vectors define their own axis of rotation perpendicular to both. That axis of rotation does not come with a fixed orientation, which means that you cannot uniquely fix the direction of the angle of rotation either. One common convention is to let angles be always positive and to orient the axis in such a way that it fits a positive angle. In this case, the dot product of the normalized vectors is enough to compute angles. x1 times x1, y1 times y1, and z1 times z1. Ln square 2, x2 times x2. Oh, so he's just squaring these. And then the angle is that.